Coming up on this episode of the IoT Inc Business Show.
When we look at the flow of data from the real world to the user, the value is at the edges. And one edge is where the sensors interact with the real world, and the other edge is where the users take action on the information that's created through the value chain of information.
No matter how we define sensor, we're a long way from a plug-and-play world. Except for the most rudimentary forms of sensing, you must be prepared to go custom-built. And if that's the case, you must have an understanding of the connected sensor and the build-buy decision. These two paths are different business journeys with different costs to consider. In this episode of the IoT Inc Business Show, I discuss this with Scott Nelson, who takes us on a deep dive into the connected sensor to understand the economics involved and the questions to ask during the sensor definition stage. This is part one of a two-part interview with Scott.
All this and more on this episode of the IoT Inc Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc Business Show. This show is made possible by sales of my book, IoT Inc, published by McGraw-Hill, and the IoT Inc Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 4 is Dr. Scott Nelson. Scott is Logic PD's CTO and Executive Vice President. He has over 25 years of technology and product experience across a variety of industries, and over the last 10 years, Scott has been helping define and develop Logic PD's connected device offering, and has experience in delivering solutions from design and engineering all the way through to manufacturing and aftermarket services. We spent the last 3 shows on sensors, but given Scott's hands-on experience as a system integrator, I thought he'd be able to give us a great perspective on implementing the front end of an IoT deployment, something I believe that is near and dear to his heart. Scott, welcome. Thanks for joining me.
Thank you, Bruce. It's great to be here.
So I did not know. It's Dr. Scott, is it? What's your PhD in?
It's in physics. I actually, that's part of my background. I'm a physicist by training. I work amongst engineers who tend to tell me I might know how things work, but they make things work. My background is it's actually very relevant, kind of to what you're talking about here, though, because I'm a solid state semiconductor device physicist by training. That was what my degree was in. So I have a lot of kind of special interest in semiconductor devices, all things MEM, all things CCD, all things CID, so that kind of gives me from a systems level, knowing how things work all the way down to the doping level in the devices is kind of unique, I think, for a lot of people who do systems integration. So.
Nice. Well, give me a little bit more background on yourself. What's your background in IoT?
Yeah, well, it actually started right out of school. I went to Honeywell, and I worked at the corporate R&D center at Honeywell, and I started there, in sensors, actually, electro-optic sensors. Even worked on, at the time, right when I came out of school, there were the ceramic superconductors had just come out, and people were anxiously pursuing making new sensors out of the superconducting devices. I spent some time with that. That turned out to be not as promising as people had hoped. So I ended up more at a systems level with a lot of electro-optic sensors for a variety of aircrafts and vehicles. And then really where I kind of started in what I would call IoT was when we started to work on miniaturized displays and miniaturized cameras, which then moved us into what was known as Land Warrior at the time, and it was basically soldier systems. Honeywell was the premier head-mounted display manufacturer for aircraft, and I was a systems person on that. And then Because I was working at the front end with DARPA on miniaturized technology at the time, we essentially started implementing wearables. So we were implementing wearables on soldiers in the mid '90s, and of course, being in a company like Honeywell that was diversified across avionics and commercial and residential. We took that technology in the R&D center to everything from operators in oil refineries. I was part of a team that was one of the first people to install Wi-Fi in an oil refinery. Lots of head-mounted displays with 3D capability for surgeons, orthopedic surgeons in particular, or endoscopic systems. So I worked on a lot of wearables, kind of long before the hype of wearables today. But because of that, I have a lot of kind of classic experience with everything from, all the accelerometers and things that are common that everybody's wearing today, like myself and my Fitbit. We were, some of the, Honeywell was one of the early integrators of MEMS MEMS accelerometers on their gyros, and then eventually developing MEMS gyros. And so my background is actually a lot longer than a lot of people might think, just because we were working in environments, the soldier environment and the industrial environment, where connectivity and connecting things was very commonplace.
Yeah, and it seems the Internet of Things eats all other industries. It's like all of a sudden everything's been rebranded, and you can, I look back at my career too, and I can see, wow, I guess I've got a lot of Internet of Things experience also.
Yeah, yeah, that's the case. I mean, it is the case that there's a lot to learn by looking into the past, and it's advice I give to a lot of our new engineers when they come in is to, before you start on anything that appears to be brand new, you should always talk to some of the people who've been around a while, because they may have tried some of the things that you are about to try, and they may save you some time. It's the nature of technology development.
Yeah, no, interesting. Well, tell me a little bit about yourself. What's an interesting fact that most people wouldn't know about you?
Yeah, I think something that a lot of people don't know is I bake a lot of bread. So nice. I love artesian breads. I do a lot of bread baking. Bakers are chemists, basically more than cooks. I also cook a lot, but I really love baking. I minored in physical chemistry, but I think I must have been an organic chemist in a previous life, because baking is all about organic chemistry.
Nice.
So that's kind of something most people don't know because unless you live here and eat the bread I cook or bake.
So what type of bread is it? My wife is a specialist on banana bread, zucchini bread, and of course this season we're into pumpkin bread right now.
Yeah, that's right. My wife actually makes zucchini bread. I make a lot of banana bread, but mostly I'm making yeast breads. So I make a lot of focaccia.
Yeah, that's right. Those are more loaves.
There's quick breads. I love quick breads. I mean, they're quicker, right? I mean, some of the breads, some of the breads you make a sourdough bread, you can start at the middle of the week and eat it on Sunday, so. Most of my breads are 2-day breads. I usually start something the day before and then make it the next day. While you're working around the house, it's one of those things where it might take 12 hours total time, but it's 40 minutes of hands-on time. But of course, you can't leave the house while you're making bread.
Yeah. And then, of course, when you're eating it, it's enjoying time.
Well, that's right. And the nature of homemade bread, of course, is it doesn't have any preservatives. So you basically have to eat it all in about 2 days, otherwise it goes stale real fast. So.
Yeah, it's funny. My daughter carved a pumpkin just like last weekend, and usually these things are fresh. I went to their front door stoop, and it was completely looked like it melted. It all molded down. I was like, wow, I guess this thing was older. Maybe they got an early shipment. But yeah, I like the bread, no preservatives. You know what's going in your body,
right?
And we've got a loaf. I generally my routine is in the morning. I cut a slice off about an hour after I wake up, and that sort of takes me to when I'm going to eat. And I kind of look forward to it every day. Now, how would you classify Logic PD? I mean, as what? How do you guys classify yourself as a company? That's for one. You're a lot larger than I expected. And I guess I would have classified you as a system integrator, but it seems you guys do a lot more than that. Or how do you guys classify yourselves?
We are a system integrator at the highest level, but we're a system integrator at more the product realization level, meaning that we aren't a system integrator in kind of the IT sense where you buy some things and integrate them together, maybe do software. We have the ability to design, manufacture anything that's needed as part of the system. So we are more of a product realization type of system integrator, but because we have everything from industrial designers, we have world-class industrial designers. Our legacy company's over 54 years old, and our legacy goes all the way back to industrial designers that came out of General Mills at the time, 1960 here in Minnesota. To now all the way through to, we offer full subscription services. So not only can we manufacture the product, but we can provide for our customers who are often mid-market OEMs, we can provide for them the ability to provide a subscription service or a continued value service to their customers without them having to build the infrastructure. Similar to, we can manufacture things for them without them having to build their own factories. It's that type of solution. So, that's, what really sets us apart though is our, as a system integrator, what sets us apart is our legacy of design. Our designers, I like to tell the engineers, engineers can make things that work, but designers help us make things that matter, make things that people use, right? And that's really key for us.
Yeah. So interesting. Now you mentioned OEMs as being your customer. So do you work more with OEMs than, let's say, the end customer itself? I'm thinking in the case of just a random example of a sump pump. I don't know. Yeah. I mean, would you work with an OEM that's going to resell a sump pump, or would you work with the sump pump manufacturer, or are we getting close? Maybe that's a bad example.
Well, we actually will do both, and particularly with the IoT now. But traditionally, kind of pre-IoT, we would have primarily worked with the sump pump manufacturer. Right. They would have come into us and they said, we want to build a new sump pump. We want to make it connected. We need to figure out what radio that we can put in this thing that.
Oh, right from the beginning.
Right from the beginning, yeah. And so then, but as part of our process, we would then go out and interview, and the designers would go out and interview and audit the users of the product and make, so we would interact with the users. We wouldn't sell to them directly, but we would then, after interacting with them, we'd work with the manufacturer and help them design and maybe manufacture the product that they would then sell. Now, since IoT has come along, we will also talk to people who want to buy a service. For example, we call them buyers as opposed to manufacturers. So this is somebody who has the classic example is anybody who's doing logistics, and they might come and say, I can't find this, but I would like to have, a product and a service. I'd like to buy a product that does this particular thing. It needs to monitor, my beehives, and it needs to tell me when I need to go out to the beehives and do things and so on and so forth. And I can't find anybody that will sell this to me. Can you guys, could you design this? And so they are more buyers than they are manufacturers, but a lot of them, will have the foresight to see that they are maybe one of many that would use the product. And so then they're looking for a partner who might build it for them, and then they might actually license it or sell it to others. Depends upon how big they are, depends upon how innovative they are, to be honest.
And so that's who just so I understand, that's who you would be categorizing as an OEM then in this situation. Is that right?
Yeah, an OEM, original equipment manufacturer. Sorry, it's the acronyms. Kim tells me to be careful with acronyms. But yes, the OEMs are what we view are the people whose essentially brand goes on the product when it heads out into the marketplace.
Right. Okay, well, I like to start from the beginning. And so again, our listeners are business folks. They are figuring out how to approach the IoT space. And let's say that they've done the prerequisite planning in advance. And, this is something that we haven't really talked about yet because we're starting with technology, just so, so everyone understands what they are, what they're talking about and what they're planning and buying. But let's say they've figured out their business plan, what are the steps that a company should go through to start the selection of their sensors? I mean, I presume that's the first step, although maybe I'm wrong. But what would be the steps?
Yeah, well, there's a couple of comments I'd have to that. First of all, the statement about do you start with selecting your sensors? In some sense, the answer is always yes, because in our world, sensors are at the edge. And when we
that's what I would think,
look at the flow of data from the real world to the user, the value is at the edges. And one edge is where the sensors interact with the real world, and the other edge is where the users take action on the information that's created through the value chain of information. And so, yes, you do focus on the sensors, but at the same time, this comes from our system integrator point of view. We always start at the systems level. We have a process for, specifically tailored for IoT, where we've combined traditional product systems engineering with what we might call business engineering or business development. It's called Adrenaline. And Adrenaline starts with a workshop that really focuses on the user and finds out what is the value proposition. So we jump all the way to the other edge and we say, what is the value that we're going to create? And then we work through back through the technology. Okay, what technologies do we need to create that value? And we will get very quickly then to the sensor. But we have to understand the value proposition of the sensor to properly, either design it or select it. And then we will very quickly move into in an agile process. We use a process, lean startup process methodology. We'll quickly build that technology implementation, and then head into what's probably the most important thing in IoT these days. And I say this again in the sensor context, because if you create a proposition that you think is going to be valuable in this space, it has to be valuable, every time the customer touches it or uses it. And that is that's a statement that you kind of test in the field very quickly, and you need to test it very quickly so that you don't kind of waste money doing the wrong thing. And we do a lot of pilots to do that. And I'll talk about IoT off and on today. I know we're talking about sensors, but I know one of the things you asked me to look at were trends. And, IoT, I was looking up some numbers. IoT is anticipated to take us from, roughly, I think it was like 10 million sensors in 2007 to 1 trillion sensors in 2020. And we do spend a lot of time thinking about sensors in the context of the Internet of Things, because people are putting sensors on everything, right? So that's kind of
and I think you're right, and you first have to figure out what the value is you're creating, quantify the value, and then as part of that value proposition, or as part of creating that value proposition, you're sensing the world. You need data, you need information, and that's obviously where the sensors come in. That has to be tied, directly 100% to your end product, to your end goals. So let's take that as let's just take that as gospel and consider that's the case. All right. So now we know we need to do this, and that. What are the first steps? What do we do now?
So classic systems engineering, you start with an architecture, the overall system architecture that is going to be used to implement the solution. The architecture then advises what we call an analysis of alternatives, and you make an analysis of alternatives at every major part of the architecture. The sensor will actually be one of the areas where you'll do the alternative. And so if you're trying to sense let's say you're trying to sense the orientation or position of something, your alternatives, and I've done this many times, of course, your alternatives can be inside out or outside in, for example. I can try to put inertial sensors inside the thing I'm trying to measure, if that's possible, and maybe use MEM sensors and accelerometers and things. Or I can say, no, I can't get inside of it, but I can see it. So I'll build some kind of video, image processing system that will do my orientation. So you'll do alternatives like that to help pick what type of sensor will get me the information that I need. Then you move through interface controls. You have all your kind of functional blocks or your architecture blocks. And then you have to figure out, how does everything talk to each other? Do I need, is the sensor I end up with, does it come with, A to D conversions or data conversions? Does it give me what I want, or does it give me raw data? Do I still have to convert, the sensor from a pressure sensor to some kind of, volume sensor, for example, or, what is it I'm really trying to measure?
Yeah. And I want to just sort of interrupt you here is I catch myself doing this all the time. And that is, I use the word sensor, and what I mean is IoT sensor. And what I mean by that is not just the actual sensing device, which, outputs usually some sort of a voltage, but I mean and I don't even know what this is called, so you can educate me here, but I mean the connected sensor. So I mean the sensing device plus, the energy, whatever that's going to be, plus the network connectivity. What do you call that? I call it an IoT sensor as opposed to just a sensor, but I'm sure I have it wrong. Is there a name for that, or do you know what I'm talking about?
No, I don't think you're wrong, because you're actually working to address what is in some sense, a semantic transformation. Right? I mean, originally, I would argue, when I first started working at Honeywell, a sensor was basically also synonymous with a transducer. Right? It was synonymous with something that would output a voltage or a current. Right? I mean, you had a couple of different types of sensors. You had those that put out voltage and those that put out currents. Right? I mean, because they're part of an electrical circuit, right? And
transforming one energy into another. That's
right. And then eventually they transform into things that put out frequencies and phase, but they, I would classify them as a physicist again. I look at them and say, those are transducers that measure specific phenomena, physical phenomena. But your word IoT sensor, it would need to be defined, because I don't think it's a universally defined term yet. But I liked your definition. And in fact, I got a paper submitted to another group that I'm going to talk about sensor APIs. APIs are rampant throughout the use of the internet, right? And what does an API for a sensor mean? Well, an API for a sensor would mean that you would basically provide an interface document to a software engineer that would allow them to use the sensor without knowing anything more about it other than what the API tells them, right?
Yeah, assuming it was a air quote IoT sensor. If it wasn't, then the API would be an A to D converter.
Well, that's right. I mean, right? And API is very much a kind of an IoT acronym today. But you're absolutely right. In the generic form, the interface is, what is the interface? That's we call, the IC, the interface control document, would define what is my interface. A lot of sensors today, have digital interfaces. They convert from the analog to the digital very quickly and historically for a broad number of regions, not the least of which is the shorter the analog path, the less issue you have with noise and interference, right? But it also makes it easier to use, which is a key value proposition to system integrators like us, right? The easier it is for us to plug it in, the better it is. And these are the kind of the transforming parts of the sensor manufacturers today, is trying to figure out two things usually. How do I differentiate myself from other sensor manufacturers? And secondly, how do I make it easier, for my sensor to be integrated and used? How do I make it more valuable to the system integrators and designers? And the things you mentioned are typically what they do.
Yeah, I mean, and not to go off too far on this tangent that my self-induced tangent, but yeah, I mean, sensors have been around for a long time, obviously. They've been commoditized to a certain extent, obviously. However, this IoT sensor or whatever, and I was wondering if there's a name, and maybe not. Maybe it's IoT sensor as good as any, but maybe this is a way for these manufacturers to start getting some margin as well, because the value, I would suppose, is in this interface.
Yep.
And
absolutely.
Being able to, communicate with it.
Yeah, a good example, you and I spoke before about a product we developed for a customer called Whisper. And Whisper is essentially a lung health sensor for cattle. It reads out 1 to 5, and the 1 to 5 is a lung health measure for cattle. Well,
so how is it used? I mean, what's an example of how it's actually used?
So when a feed yard gets in a shipment of cattle, they can measure, they can put this stethoscope on the animal, and they listen to the lungs. It diagnoses, it takes an 8-second sample, audio sample, which we then convert into this diagnostic measure. And then the measure, a 5 is actually a very sick animal, but the measure then indicates what the treatment is to get the animal back to health. And so it is used to help, reduce the loss of animals in the process, and also increase their health immediately as soon as you have ownership of them. But the sensor, you could argue the sensor in this is a microphone, right? But today, as an IoT sensor, it's a lung health sensor, and and of course, you're absolutely right. If you create what you were calling an IoT sensor, it's going to be somewhat application driven or application specific, and as such, you're going to have added value to your sensor significantly, right? And that is valuable. And there are many people, system integrators like us, who understand how to use sensors like that. So one of the things that we're doing is taking the data that comes out of those sensors and creating new measures, crafting new protocols for working with the animals. And that particular customer today has not only figured out how to treat sick animals, but they've now figured out through various big data analytics how to identify the strongest and healthiest animals, which now gives it a sorting capability in addition to a treatment capability.
That's interesting. Yeah, and that's like I guess it's just an overloaded term, but I think it's helpful to, qualify it a little bit. But anyway, I interrupted you. I think you were on interface control. So we're going through the steps of selecting the sensors, and you were on interface control. So this is, in a sense, which ones, I guess the question is, you were saying you do the system design, and I always wonder, is it the sensor or the platform that comes first? Are you implying that you've got the platform in place and you are now delimiting, or you're now filtering the sensors that are possible to work with that platform, or do you mean something else?
Well, if I go back to your original question, and I'll answer it in two ways, just so you know. It is very possible that someone has figured out how to make a new sensor, which then precipitates a new business plan, right? Now, they'll apply that sensor to an application. And so then what we as a system integrator would do is we would more or less have that sensor selected. That would become a known part of the architecture, but we'd still architect the system. And we'd make
around that sensor.
It would be around that sensor, particularly if it's a unique sensor. So in the case of Geisler Corp with the Whisper sensor, they had a methodology to create the sensor. They did not, however, have a microphone picked. Right, so we helped them pick the microphone, but the concept of the end sensor was already defined. We didn't change that. So it in some sense, it depends upon the business plan. If the business plan is uniquely tailored to a particular new sensor, then obviously we're not doing an AOA on the sensor, but we're doing an AOA on everything else, and we're working out all the interface controls. We may change the sensor and how it's used in order to facilitate, the better integration into the overall system, right? But we don't do what I would call a full sensor review unless, when the sensor is already identified as being unique to the application.
Now, is this, I guess, identification done through some sort of a formal, research, or is this the customer comes to you with it, or is this kind of all of the above?
It's a formal process. The AOA is a formal process. The tools that one uses, the web, of course, provides you with a wide array of tools to search on sensors of different types. We have a lot at Logic, because we work with so many companies on different sensors. We'll have an array of experiences with particular partners. There are there are companies that visit us every month or so and explain to us all their sensors in their product line and what they're doing.
Okay.
So for us as a system integrator, people make us aware of their sensors,
right?
And we get we monitor things like Sensors Expo and Sensors Magazine. You keep track of our engineers keep track of what's available. There's both kind of recurring tools, and then there's historical tools for doing things and making certain measurements. Okay,
so steps. Then you're identifying this sensor in some way, and then you've got a short list, and then what happens next after that?
usually when you the kind of the last step is what we would call a make buy. I mean, some people would say systems engineering is a lot about being smart buyers and smart makers, So sometimes we'll look at something and we'll end up looking at it and decide, can we make it or buy it? You usually can buy, at the transducer level, but you will sometimes make decisions on things like you mentioned, integrated A to Ds, integrated processing and processors. You'll make decisions about, do I want to take control of the analog front end myself? Can I trust what's already built? So there are make buy decisions around the level of integration, and that's gonna increase, in the context of your IoT sensors, because to build it's like building a module of some sort, right? When you build a module around a processor, for example, you make a lot of decisions about additional components, and you make decisions about software. And as a system integrator, we might disagree with those decisions, and we might end up in our own make process. If we like what's been done and it's got enough flexibility, then we buy, and then we integrate and we buy with the interface controls.
Yeah, and I think this make buy is an interesting data point in the evolution, I guess, of the industry. The holy grail, and I've written a white paper on this one, is interoperability, and whatever that means. And again, that's another overloaded term. But I'm interested. You're on the ground. What's the percentage right now of the make buy right now in these decisions? What's the proportion between the two?
Percentage wise, my gut feel would be it's probably heavy on the buy. As a system integrator. I mean, we have a lot of options, but it's probably not, heavy meaning it's over 50%. But I'm trying to think about all the different things that we've done. But we and kind of think about how you would define your line of where is it an IoT sensor versus not an IoT sensor, or where are we building something. It's probably 60-40 or maybe it's closer to 50-50 if I talk to all the engineers. The other thing that I have to be careful of course, is that we integrate a lot of sensors into some of the systems we build. So some of the sensors are very rudimentary and they're always just buy sensors, and others are more complex. We built an evaporative light scattering detector for Grace Davidson that had, I think, 27 different sensors in it when we were all done. RFID sensors, UV sensors, infrared sensors, thermal sensors, and some of those were make absolutely from the ground up. Well, in fact, if you think about it, it's an evaporative light scattering detector. The whole system is a sensor in itself, right? Sure. There's a philosophical discussion about, where does the word sensor end? When you're building an instrument, in some cases you're building a sensor, right?
Yeah, no, absolutely. And well, it's interesting because, as listeners to this podcast, they are considering building a connected product. And then, it's just to give perspective, darn, am I going to have to actually invent the sensor too, or design, and engineer a new sensor? I know I'm going to have to do a lot of custom other work, but am I going to have to even do it at the sensor level? And what you're saying, 50-50, maybe even 60 or 40-60 if we do make versus buy in that order.
Well,
okay, no, that's helpful.
And to your point about the IoT and the plug and play, the key to this, and it's actually the burden of IoT right now, is going to be the standards. It's going to be the plug and play standards. And sensors live at pretty much the far edge of the IoT world. And so for the most part, they live at the low power, low bandwidth, very low cost edge of the IoT cloud. And the radio choices out there are challenging, and it's challenging in two ways. One, they're challenging in that they can be viewed as a very high expense add to somebody who's building a sensor, because sensor costs are cost pressures are always pretty intensely down. And then the other problem is, if I'm working in an industrial space, which radio do I put on my sensor? There's so many of them that it's hard to figure out which one to put on, and that every integration at that level is a gamble.
Yeah, on one hand, you're right. I mean, it adds cost to the IoT sensor, but on the other hand, doing an overlay approach is probably a lot cheaper than maybe doing the alternative of wiring it or somehow accessing it in a different way. And I suppose it really depends. I mean, a question I have for you, for your business, are you mostly focused on making connected products or connected environments, which would be maybe like a manufacturing environment, or I guess it could be an infrastructure visit, or is it mostly you guys focusing on it seems like you're more focused on the connected product than the environment.
Yeah, I think
is that correct?
I believe, yeah, that's accurate. I mean, we're usually creating a new product that's connected. Most of the connected products will have a connected infrastructure that has to go with them. Yes. And what I mean by that, of course, is gateways that will get you eventually to the cloud. Some of the products connect directly to the cloud, but many of them do have an infrastructure. They'll have a topology of network architecture that will support the product that we're developing. And but the as you move away from the edge, the buy decisions get much, much larger. So I mean, it's very rare that today it's very rare that we have to build a gateway. It almost always is a buy.
Yeah. So let's go back on the edge. So you've talked about I guess the interface controls. You've talked about the APIs, and you're meaning both. I guess on the media layer, and then working our way through the different layers there. What else are you taking into account here during these steps of finding your sensor?
Yeah. Well, eventually we'll get to I guess you'd call it performance. Okay. You get to what level, and you start to do your trade-offs. I mean, you get to the point sometimes what type of sensor you're going to buy, but you'll have a range of performance characteristics. And they can range from very different decisions. I worked on night vision cameras a lot when I was working with the soldiers, and we were doing we were putting image intensifiers in front of CCDs, and today the number of $99 game cameras that sit out on trees here in Wisconsin and see deer in what looks like a night vision environment, and they're much lower cost, less complex solutions than an image intensifier, but they also work differently. And
right.
We make decisions about active versus passive and so on and so forth. So you will have to make fundamental decisions like that. But more often, you're going to have to make decisions like on the A to Ds, where how many bits of A to D do I need? You have a sensitivity. I want to make. It's a big mistake when you build a system that's too sensitive and you get a lot of false positives or false negatives, right? So when you get down to the final details of the sensor, you're often deciding how to implement that sensor in the overall functional loop from an accuracy and resolution point of view.
Yeah, good point. Let's go back to the performance, because I presume if everyone could just have all the performance they could get, they would be happy with that. But I guess it's price performance is really where you're going with that. So let's talk about that. Pricing. Let's get just give me some ballparks again. Just consider the listeners. How much do these things cost? Are we talking about $10 each? Are we talking about $100 each? Are we talking about $1,000 each? In the context of the customers that you've been working with.
Well, it's interesting. So just yesterday, I worked on 2 different projects. One of them was a body-worn sensor to measure movement of limbs, and
Okay.
We're talking about probably dollar or sub-dollar 5-axis MEMS gyros that are that low a cost because
because they're in your phone.
They live in the cell phone world, right? So they're easy to acquire. And earlier in the day, I was meeting with a company that has very highly instrumented run-out sensors for motor shafts that is actually looking at integrating one of their sensors into an implanted device. And these devices presently are used in a space where they cost thousands of dollars each. And The reason for that is the the complexity of the sensor itself, basically the hands-on manufacturing required to make the sensor, as well as the as well as the value that they have created in the signal processing that they do, in this case in an FPGA, so it's proprietary signal processing that they've learned to do over the years. And, so we got $3,000 each down to 90 cents each in the same day. So there isn't really an easy answer there, but
it's a range.
Yeah,
I mean there is a range there, although it's a pretty wide range.
And the histogram is going to be. I would say the histogram is 90. You probably got 90% of your costs in under $50 for the most part. Right?
For the customers that you deal with.
Yeah.
Mm-hmm. And is this a function for overall cost then? Are there going to be more of those sensors? I guess not in the one you were talking about for the limbs, because, maybe. Well, no, not for a so-called deployment. But overall cost would be cost of sensor times number of sensors. So these, in the histogram at the under $50 mark, what's the overall cost? How many of these sensors are they buying, or is it just one per product?
Yeah, let's see. I'm thinking. Like I said, we had the one ELSD that had like 27 different kinds of sensors in it, and some of those were camera sensors, so those were not
super expensive.
Well, they weren't. There's even CCD cameras these days. You're still under $100, but you're not at the 50, right? And now it's if you get the whole camera with the formatting and everything, but we sometimes are just integrating the sensor head and then doing the camera work elsewhere in the processor. But the over what percentage? I think is it fair to say what you're asking is what percentage of a BOM cost of a typical product is made up by this what we would call the sensor? Although that is of interest to me, but it was more like I'm just trying to get my arms around the costing on the sensor side, and for a typical product that you deal with, and again, I guess you need to look at that histogram. You were saying, it's probably around the $50 mark, and then I'm wondering, is it just one of those $50, or are there going to be multiple of those $50 for one BOM, I guess, for one product? Yeah. If we talk about the connected space and the IoT space, we're typically implementing kind of one sensor per unit. But the sensor, the sensor is the reason we're building that product typically. So the sensor makes up majority of the value of that thing, and therefore it ends up being a significant portion of the cost of goods.
Now, the cost of goods being the added cost of goods, because I presume if you have, let's go back to our sump pump. I suppose this brings up the other case, whether it's an aftermarket IoT sensor or if you're talking about doing a new sump pump. And in this case, we're talking about doing a new sump pump. Is that it, or is it a kind of a bolt-on addition to the sump pump?
It's interesting. It's a very interesting and actually leading question. Intel has kind of done an analysis of the IoT space in the industrial space, and some of the most talked about IoT areas are, by GE talking about the $15 trillion. Sure. And the interesting thing about that, first of all, is that $15 trillion comes from a 1% improvement in systems. Right. We're in an asymptotic level. But GE, if you read, they recently had an article in Fast Company. If you read that article in Fast Company, they talked about the three phases of performance improvement using sensors, using IoT. And from GE's point of view, it is a sensor-driven methodology. And but it's incremental. It's one step at a time. And they have implemented sensors in the engines and moving terabytes of data. So they've really focused the value proposition is at the other end, but it's all coming from this deployment of sensors. And they live in a retrofit world. Intel said that this world, this industrial market, 85 to 90% of the equipment out there is not connected, right? Meaning that they are not getting data off that equipment.
Right.
And we at Logic look at that as a very, very big opportunity to retrofit sensors onto equipment, because most of that equipment has lifetimes ranging from 7 to 25 years.
Absolutely.
And in this number that I read this morning, where we go from, I think today we have about 3.5 billion sensors deployed, and if we're going to get to a trillion in the next 7 or 8 years, we're going to be retrofitting a lot of things, right? And
and I think there's a couple points I want to discuss on this. The first one is, I have a pet peeve on IoT reports that talk about just the improvements. And, when you're looking at it from a business perspective, it's not just the improvement, it's the cost that you need to invest to make that improvement. And so that's why I'm trying to drill in, on these costs, Scott, because, it's one thing to say, a 1% or a $15 trillion savings. Okay, well, that's great. But how much money are you spending overall to make that 1% or that $15 trillion savings? That's the part that's never talked about, or at least that's the part that is maybe a little bit more difficult to ascertain. And that's why I'm being a little bit stickler on these costs, because I think it's very important when you're building that, when you're quantifying the value and the ROI, you need the I part of the ROI, not just the R part, which is what is often talked about.
Right.
And so going back to the other point that you were making, if you are in the case of when you were saying you're building a product around a sensor, I'm assuming that is a new product, and so it's an embedded environment as opposed to the retrofitted one. And then let's talk about the cost then of that sensor as part of the product. I guess, again, that really varies, because the product could be a very expensive product or inexpensive product, but the sensor would change percentage-wise depending on that situation. Are there any rules of thumb there in terms of the cost of the IoT sensor for the new product? Because, hey, I have my sump pump. I want to develop my new product, my connected sump pump. What's going to be the cost differential on making that sump pump a connected product? And then obviously the second part will be how much more can I sell it for, but we're not going to talk about that part. We're just going to talk about the cost part. Can you shed any light there, or am I being just too abstract?
No, I understand the question. So if I think about the sump pump, what is a sump pump? It's a pump. What does one measure in pumps? Typically, you either measure pressure or flow in a pump. Mm-hmm. And, pressure sensors can be complex. It depends upon the environment in which you have to measure pressure and whether you have to measure differential or absolute pressure. But there are very cheap pressure sensors, and flow sensors are a little bit more interesting. We're actually working on a device right now that's using flow sensors in a high volume application. In that product, it's a connected product with a flow sensor. The sensor itself is highly integrated. The sensor is integrated with the power supply. It's an energy harvesting power supply. So you go back to your point about adding value. This is an area that your audience should be investigating. When we as a system integrator can find a sensor that somehow removes the need for batteries. Batteries are the biggest enemy to the IoT right now. And that's a value add point. But in that device, the sensor was costing probably 60% of the BOM cost. Okay. But it was a value add sensor. It had energy harvesting and had other things in it. If I go to your sump pump, I'm going to expect that I can find a fairly simple, not new. It's not a new technology. It's going to be a very mature flow technology, and I'm probably going to be, almost invisible from a cost point of view, but not totally invisible. It'll probably be in the few percent of the cost, of the pump, depending upon how sophisticated the pump is, of course. But I also have to add the connectivity, and that's going to be an added cost. When I add the connectivity is where I'm going to jump the cost. So
because it's an IoT sensor, and
if I add the connectivity because I have added the sensor is then going to get credit for the cost. Right.
Right. Yeah. And so then what does that bring it up from a few percentage points to what?
Yeah, it could be, then you could jump up into the 10 to 15% add on already, particularly if you're in a mature world like sump pumps. This is where the retrofit world is interesting.
Yes. Yeah.
And that's, if you've got mature technology out there that's not doesn't have any electronics, and you bring in sensors and communications, you can double the cost of the product if it's a really simple device, a really simple piece of rotating equipment, for example.
Yes.
But the value prop isn't going to be about. The value proposition isn't going to be just about what you sense. The value proposition is going to be about what you prevent. It's going to be about what you offer or prevent in it. We actually say, we're talking about cost a lot. We actually, when we do our adrenaline workshops and customers bring up cost, we actually tell them in the workshop, cost doesn't matter. Cost doesn't matter. We are living in the heart of Moore's law right here, and every day cost goes down. Sprint lowered all their connectivity costs again yesterday. Cost doesn't matter. Now, I say that because we don't want them to think about the proposition in a cost plus format. You have to think about the proposition at a value level.
I agree.
And then you come back to what you said. Okay, now let's go look at the costs and let's calculate whether or not we can make this move. Let's calculate whether or not we can afford to put these sensors on all these motors. Because if it doesn't add enough value, then, well, no, the cost doesn't justify the move, right? And you're absolutely right. The 1 trillion, is hype, right? And we're at the peak of the Gartner hype cycle with IoT right now. The 1 trillion is hype, but I kind of believe it because 1% improvement is typical. That's typical GE business model, right? It's improved by 1% every year, right? So
yeah, no, I don't deny it. I just want to know how much that 1% is going to cost.
But what's the margin of the 1% is not discussed. That's absolutely right.
That's not discussed at all.
That's right.
So on the sump pump example, 25% up to 50%, and then of course, like you were alluding to, depending on the business model. If you were just to sell it in the same business model, then you'll have anything over it won't be exactly a 25 to 50, but let's say a 27 to 55% increase. Anything over that in the price of the connected sump pump would be extra margin for that product, assuming the same distribution and all that. Then that would be kind of the business model in a nutshell. Am I there?
It is one version of the business model, depending upon the value proposition.
Assuming it's sold the same way. That's right. That's right. It's just a connected version. Well, that's it. You buy it for this price instead of this price because it's connected.
But that actually, we don't advise doing that anymore.
Okay.
We don't advise selling. If once you connect the device, yes, you sell the device, but we call these transformational new products. They transform your customers into subscribers. And so why did I connect the sump pump? Well, most likely I connected the sump pump either to make sure it's still operational or to know when it operates. What's the value of knowing that? Knowing that my sump pump is properly draining my basement can be worth thousands and thousands of dollars. It's an insurance play. What am I willing to pay to insure my basement? Well, I might be willing to pay $100 a year. So now all of a sudden I might say, I'm going to give you the connected sensor on the sump pump, but you're going to pay me $100 a year from now on, right? And so it's not the same set of considerations once you connect.
No, it's not the same, but we have to also be careful. We don't believe too much in the hype either because, we use an example of a lock. And you're right. I mean, the lock, the value proposition, let's say it's a connected lock, and let's say I have a key in my mobile phone, and when I walk up to it, it unlocks my door. That's all great. And when you look at the value proposition, you're saying, well, maybe that's a different type of lock, and you can sell it as a lock as a service, and there's a cost. But you have to also consider, there's obviously a lot of other dimensions to consider because I want to buy a lock. I don't want to buy a service to unlock my door. Maybe if it's part of a security service, that's another I guess situation, another case. But I guess I just want to emphasize that it's not always a different business model. Sometimes it's the same business model, just a new product.
Well,
would you agree?
Well, yes. Although I absolutely agree with your analysis of the locks. And actually, I wrote a post about an egg holder that was GE was all excited to tell me if my eggs were fresh or not, and I'm like, I'm not going to pay for that. So the first thing I would say is not all connected products are viable or make sense.
Exactly. That's true. That's a good first point.
But what I might counter is why would I connect if the connected model doesn't make sense? I mean, basically, that's what we discuss in our adrenaline workshop. Does it make sense to connect? And if the value proposition doesn't improve to the point where it makes sense, then we would not advise doing it. So
and I thought that's what you meant.
Yeah,
I mean, that's the no-go right from the
you're absolutely right. Yeah, I mean, I can't. I don't know if there's a connected sump pump out there right now. My guess, to be honest, is that it's still a very expensive proposition because of where the sump pump lives, and there's probably an easier way. There's probably an easier way to get the information. I probably would put a flow sensor on the output, which is easy. And then I get the same information that I would have gotten from the pump, and I've got an easy retrofit. So, but you're absolutely right. There are going to be a lot of products that people will say, I'm going to connect them. I'm going to put these sensors on. I'm going to monitor it and know what's going on. But they aren't going to be viable business cases. Is really, I think is the way I would restate what you said exactly. Yeah.
Well, listen, Scott, I feel as if we're just scratching the surface here, and I like to call this part one.
Okay.
Let's call this part one, and let's bring you back for part two.
Okay.
Before we do that, I want to end this as, okay, Logic PD, how can people find you? How can people find Logic PD? How can they get more information?
Yeah. Well, we have obviously logicpd.com, our website, but really on the topic you and I have been talking about today, Logic PD Insights, which you can get to from the website. That's our blog posts, and we talk about our experiences. We highlight our case studies. The Whisper case study is there, for example, and that's a really good way to get an understanding of our point of view in our philosophy on things, and that's really, I think, those two sites would give them access, and they of course can contact us through either of those web pages and get right to myself and other team members right through there.
All right, and do you know offhand if people want to just connect with you with social media? I can get this, obviously. What would be that way?
Well, I have a Twitter. I tweet as part of my role, and I think you have my Twitter address.
I do. I will put it in the show notes.
And then Logic PD's has a Twitter account as well. So for this to kind of social media, and I'm sure I know I'm Scott Nelson 19. I'm not sure what our official. It's probably Logic. It's probably at Logic PD. I think we don't have any competition with that trademark. But they'll provide you with the details on that. But we do have a lot of very active in the social media. I write a lot of posts, read a lot of things to keep track of what's happening, because this is a very rapidly emerging market, as you and your readers and listeners will know.
Yes, no, and I agree, and I think we're just scratching the subject here of what I consider is a very important subject, the front end of IoT deployments, and I want to thank you for an enjoyable discussion.
Yes,
and I want to invite you back for part two, because there's a whole lot more I think that we should talk about.
Okay, I'd like that.
Okay, that was a great talk with Scott Nelson of Logic PD. One of the few podcast interviews that actually is in two parts. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc, published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc, or the ICIP training and certification program. It's how I pay the bills. Next week's episode is part 2, Sensors from the Inside Out and the Outside In, again with Scott Nelson of Logic PD. Hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a sensible one.
You have been listening to the IoT Inc Business Show.